Welcome to the Lippis Report.
Hello everyone, I'm Nick Lippis from the Lippis Report, and thank you for joining us today. We've been testing Arista's products over at iSimCity for the better part of a week, and we're really focusing on Ethernet fabrics in this particular set of tests. Now, what we're about to show you, though, is how virtual machines interact with fabrics and how we've been able to take out all of the administrative configuration associated with both firing up a virtual machine and then also how that network fabric learns about that virtual machine, and then also when we move that VM around the network, how the network then auto-configures itself, and then at the final end, when we need to delete the virtual machine, how the network then deletes that configuration. So that's what we're going to be showing you here today, and I'm very fortunate to have with me a really great person over from Arista, and that's Michael Francini. Michael, say hello.
Hey Nick, thanks for having me.
Excellent, great. Well, I'm really glad that you're here, Michael. So first, let's start with the topology.
Okay.
And, let's show everyone what we have and what we're going to be demoing.
Okay, sure. So we'll start from the servers up. Essentially, we have some vSphere servers,
Yep.
and they're actually dual attached using two interfaces on a NIC and a lag configuration to a pair of top-of-rack switches. And that provides for high availability and also load sharing, and it highlights a feature of Arista's called multi-chassis lag.
Yep.
Okay, and essentially what we're doing is we're replicating that across all the racks in the data center, and then they're aggregating using MLAG to another pair of distribution layer switches running Arista MLAG as well. And what's neat about it is it's high availability, it's load sharing, but it leverages industry standard link aggregation protocols. So pretty much any device can plug into it.
Okay, great, excellent. So that's the configuration that we have. We have physical machines over here, so let's fire up a VM on one of them.
Okay, fair enough. I actually kind of jumped the gun on that, and I actually have a multitude of virtual machines running right now.
Okay.
What I was going to essentially show you is that we have a Windows device which is plugged into one of our switches. And what you can do is, with a feature on Arista's EOS called vmtracer, vmtracer uses the VMware standard API to glean information from the vCenter database. And that information can be shown by the network administrator in the standard command line, show vmtracer interface, and essentially it'll show all of the virtual machines that are in the in that hypervisor, what they're connected to, and also their status. As you can see, a lot of these are essentially turned off. A few of them are turned on, including the CentOS image that we're going to be playing with right here, and also the Windows image that the XP, actually not the XP, the Windows 8 image that we're playing with as well.
Okay.
Okay.
So vmtracer has basically interacts with the API from vCenter so that you can do, so it learns, understands when a VM is being established, and so then it can take that information and then do network configuration associated with it.
Exactly. So the benefit is that from the systems perspective, systems administrators use the standard vSphere client to instantiate the virtual machines, to configure the networks, to configure the vSwitches. Yeah. And through vmtracer, the switches recognize the configurations that are happening on the hypervisor and then establish the virtual networks that are required to make sure that all the virtual machines and the vSwitches on the hypervisor are connected into the network.
Okay, very good, excellent.
All right, so what we're showing you here essentially is the Windows 8 box. I can take a look at the settings on this platform, look at the NIC, like for example, I can take this, configure it to network 10,
okay.
And then as soon as I've done that, and it's gone through this process,
You can see, yeah.
what you'll do is you can first see that we have, if you do show VLAN, we have a feature that's referred to as dynamic virtual LANs. Dynamic virtual LANs are networks that are not configured in the start of configure the switch and are not configured by a network administrator. They're actually being configured by the vmtracer agent as a result of the
I see, very good. So that's a great automation feature. Listens to like vCenter, then does a configuration.
Exactly. And what's neat about it is that using the SOAP XML API, it's a publish-subscribe model, so it's automatic, it's not polling, so there's no burden on the vCenter. It's got a lot of scaling capacity to it. And also from the network administration perspective, what's neat is that as virtual machines are spooled up or are moved across from one machine to another, the virtual LANs are pruned and propagated to follow that virtual machine. So it makes topology administration automatic.
Yeah.
And that removes a lot of errors and service level issues that occur when there's a manual process involved.
Great, excellent. Okay, so we just moved a VM from one network to another network, so let's see how it responded to that.
Okay, so essentially what you can do now is look at show VM tracer interface. Let's see if I type this correctly.
Okay.
And what we're looking for is the Windows device. There we go, Windows 8. And as you can see, it's now in the native network, and the interface is up and operational.
Very good, excellent, great. Yeah. So let's move a VM then from one of the servers to another server.
Okay, so one of the neatest features of virtualization, particularly in the context of VMware, is the fact that you can actually move live systems, okay, or live vMotion or stateful vMotion. And what I have here is a couple of Linux boxes. This one here is IP address of .168, and its friend over here is pinging to it, as you can see, and it's doing it quite nicely. Yeah. So what I was going to show you was the fact that I can essentially take this this virtual machine, if I can find it, the CentOS base image. There we go. And if I click on it, and then just drag it over to the other machine, it'll say, hey, let's do a vMotion. Okay, and this actually happens pretty darn fast. There he goes, underway. It's happening,
starting.
Right? But what's neat is while that's happening, look. Stateful, pings are going, same response times, there's no impact whatsoever.
Yeah,
okay?
Very good. So we moved the virtual machine from one physical server to another physical server. We've been able to kind of ping it live as it was making that transition without, looks like any kind of packet loss, any delay. It just basically moved as if it didn't move.
Exactly, and of course the benefit there is that the systems administrator can maintain servers, can move virtual machines to higher capacity servers to accommodate unexpected stress loads. Essentially, they can dynamically provision services to meet customer demand and also maintenance windows.
Very good.
Well, the process is pretty straightforward. Essentially, you shut it down. So in this case, what I can do is, let's say, just cancel this, this process right here, and I'll do the classic. Actually, I have to do sudo. And at that point, I believe that's the right password. Oh, no, it's not here. Oh, come on. I'm doing it oh, phooey. Forget it, I'll do it this way then. What we're basically showing here is that if you shut down a virtual machine, first off, a network administrator doesn't have to be involved in this. A systems administrator doesn't have to be involved in this. This could just be a user, a virtual desktop user. Yep. That's done for the day, and they're going home, right? Yeah. So what happens is that this virtual machine will shut down. You'll notice on Vcenter that the Ubuntu vMotion, this green arrow, will disappear shortly because the virtual machine has shut down. And it's just taking a couple of seconds because the screen refresh is taking some time here. Yeah. Actually, it's still doing it. Okay, there it goes. So there it is, almost done. Okay, there. So at this point, Ubuntu vMotion is now just about off. And as soon as Vcenter recognizes that it's off, then down here, get my mouse to work. Show VM. Show VM. Show VM. There it is. So what we can show here is that the Ubuntu vMotion is now set up on this adapter, and also is on this platform. I'm looking for it. I got a whole list of these things. Where is it? Right here. Is now down. Is disconnected off. Status down.
State. Okay.
Yeah.
Down.
Right.
Dash 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 means down, down, down.
Exactly. Yeah, and it should be down. Let's take a look. Yeah, it is now. It's now down. Okay. So that's basically, a quick demonstration of vMotion running across the switches. Also with working in conjunction with vMtracer, showing how you can spool up, move, and shut down machines, and basically through this administrator console, automatically configure the network to accommodate the virtual machines and the users that are using them.
Great. Excellent. Well, that was a demonstration. Thank you so much, Michael. That was great. So in this, we did go the entire life cycle process of a virtual machine, how it starts up, how you can move it, how it gets deleted, and how there's no configuration whatsoever on the network switches in order to basically sustain the lifestyle of a virtual machine. And this can be happening, in scale, like thousands to tens of thousands of virtual machines, while we just show a smaller scale network here. So thank you so much for watching. Michael, thank you so much for joining me today.
Thank you. Thanks for having me.
Great. Thank you, everyone.
That concludes this edition of the Lippis Report. Thank you for joining us. Look for us every Tuesday and Thursday. To get your free subscription to the Lippis Report newsletter, go to www.lippis.com. To sponsor the Lippis Report podcast, send email to sales@lippis.com.